All right. Hopefully your test went okay, and the video that introduced function. Can I just say right now, I said this in my other classes, it's setting in now. I really miss you guys. I know you guys probably miss being at the school, and so we're plugging through. Hopefully you guys are making it work, and I know it's not ideal to be learning online, but there is some pros to it. But you know, right now it's like, oh man, I wish I was at the school. So anyway, just wanted to say that out there. Let me start with talking about functions and how we're going to tie. There's several things that tie into that. So we started with the chart. I did the charts of x's and y's. We talked about input and output. You put something in, you get something out. And we talked about how this is linear functions. These are things that go in a line. Well, with that line is that line's going to have a slant to it, or it's going to go up or down, or you know, it's going to have, you know, either it's going to go up like this, or it could go straight up. So that line's going to have, you know, some characteristics. It could go completely horizontal, but it's still got a direction that it's heading in. And so we talked just briefly in pre-algebra, we mentioned the word slope. And just very, very briefly, and if you didn't have pre-algebra, then that's kind of new maybe to you. But slope is talking about that degree of it going up or down or sideways. And so you have different kinds of slope that are on each problem. Now, when we did the one from yesterday or day before, x plus 3 equals y, we noticed when we put it on a graph, it followed a line. You know, if you added 1 to it, then the y went up 1, and so on. And so that had a slope to it. It had a thing that you could predict then where the next point was going to be. And that's what slope does for our linear functions. This, when it goes up from, if you're standing, like just imagine we read left to right, so think about looking at it from left to right. If you're standing down here and you're walking up, this is a positive slope, okay? And so then if you've got one kind of slanted down, you're standing at the top of the hill and you're walking down, that's a negative slope, okay? And then the two special ones is if it's straight up and down and straight across. If it's straight across, then your slope is 0. Oh, I got ahead of myself. Your slope equals 0, okay? If it goes straight up and down, then it's undefined. And we're going to learn about what falls into that category, but just for right now, that's the 4 different kinds. You can have a positive slope, a negative slope. If it goes straight across, horizontal, it's 0. If it goes straight up and down, it's an undefined slope, okay? So let's look at what forms our slope, how we can figure out what a slope is. And then we can figure out which category it fits into, and then why it matters for those different slopes. Now, if I've got let's say I had that graph from yesterday or 2 days ago. It's so weird doing it every other night class, but online especially. So we had the one x plus 3 equals y. And we talked about every time I change my x, I change my y. And I think I had us do -1, 0, and 1. We can use any number though. Let's say let's keep those. So -1 for my x made it go up to 2 on my y. So -1, 2. And then I plugged in 0, and I ended up 3 for y. So 0, 3. And then I plugged in 1 and for my x, and it went up to 4 for y. So here was my line, okay? And there was my points. And so, but we could keep going. If I plug in 2 for x, then I get 5 for y, and it'd be up here at 2, 5, and so on. And you could keep going down this way. Well, that's a positive slope, okay? That means it's going up. And how we look at that now, we're going to come up with, there's a formula for it, but the formula sometimes gives students fits, you know, because it's got negative numbers and you got to work with negatives. So I like to look at it both ways. You know, you could use the formula. If you get the formula down, it is easy to use. You don't have to draw graphs every time. But if the formula kind of is giving you fits and you keep missing, draw a quick graph like this, and then just count. You can just count for your slope. And so you can just know where the next one's going to be by your counting. Like, well, if it went over 1 here, then it's going to go over 1, and so on. You can just physically count it. But the slope is rise over run. You're going to want to write that down because I'll keep repeating it. Rise over run. However far you run back and forth is going to be also how much you go up or down. So run is going on the x-axis, and that's going to be your x's. So like, you know, if you went over 1 and you went up 4, you went over 1. You went in the positive direction. That's going to be a positive in the positive direction. My coffee's done, by the way, if you hear that beeping. That's not an alarm clock. But if you are running, then that's going to be your positive or negative down here. If you go in the negative direction, then it's a negative going this way, okay? Rise is going to be either up or down. It's going to be your y. So, you know, you're either going up for positive, going down for negative. And so let's look at this one and just see what it was. And I know my drawing's kind of crude and quick, but we can remember what this was. So let's take my first, let's go from here to here. I went over from 0 to 1 here. Okay, I was at 0 for x. This one was the 0, 3. I plugged in 0 and got 3 for y, so I went 0, 3. So I'm starting at 0, and then the next one I tried was 1, and I got 4. But see, I went from 0 to 1. Okay, that was how far I went over on my run. Okay, so my 1 is going to be down here, and it's a positive 1. I'm not going in the negative 1 on this one. I'm checking from here to here. Okay, so I went over 1, and when I went over 1, I also went up 1. So my rise was also a positive 1. Okay, and so my slope on this one is 1 over 1. And if I want to keep checking that, I'll go to the next one. We plugged in 2, and we got 5. Okay, so I went from 1 to 2, that's a run of 1. And I went from 4 to 5, that's a rise of 1. So I went 1, 1 up there. And so I could keep going. That means then on my next one, 3, if I go over 1, okay, if I go over 1, then I'm going to go up to 6. So 3, 6, it will be my next point. And then 4, 7. And then 5, 8. And so you could count. Now, they're not always that easy of 1, but that's a positive 1 over 1. That means my slope is 1. Okay, because 1 over 1 reduces down to 1. You could have a slope of 1. Now, you're going to find out a lot of times slope is a fraction. So, like, a lot of times it could be like 2/3 or 5/7 or 8 over 3. And we're going to leave it improper because we need we don't, if we turn it into a mixed number, like if you have a slope of this, meaning I go over 3 and I go up 8, well, it doesn't do any good to turn that into a mixed number. So if I turn this into 2 2/3, that doesn't tell me rise over run. So we're actually going to leave, this is the only time we're going to actually leave them as improper. So that way I know if I go over 3, then I go up 8. Okay, so because I ran 3, I rose 8. Okay, another thing is, okay, if I have negatives involved there, and I'm going to actually use a different one, but let's say this slope had been a different problem. And let's say I went from like, let's do one going from here. We don't always have to start at the origin. In fact, let's start here. And let's say our next point is here. And let's say we've got a point, if I go over 2, I go down 2, so I go over 2. So we've got this line here. If this slope, I would do my run first. So that's going to be 2, because I went over 2. And then I went down 2. So I went down 2 is negative 2, which this, if you can turn it into a whole number, you can do that. So your slope, or you can leave it like that just so we can see. Our slope is negative 2, okay? Or, sorry, negative 1. Because negative 2 divided by 2 is negative 1. So our slope ended up being negative 1, which means there's points in between here that you could put too that would fall into that, okay? But as you can see, the rise and run are going to be running either left or right or rising up or down. And depending on if you go up or down or left or right is going to be if it's positive or negative. But like I said, on some of these points, it may be just as easy to count them. And I'll do one of the problems and do it both ways so that you could decide which way you would want to do it. Okay, let's look at the formula so that if you're going to plug them in just as a formula, you can use that as well. So here's the formula for that. And it looks kind of weird, but it's actually not as hard as it looks. And these, just first thing I want to point out, these are not exponents. This is not y squared. Otherwise, I would have wrote the 2 up here to be y squared. These are just saying the second y minus the first y, the second x minus the first x. And here's the dirty little secret about this, is that it really doesn't matter which one's your first or second y, but it does matter once you pick the one, then you got to keep it the same throughout the problem. So let me put a thing up there and show you what I mean by this. So here's a point of 4, 2, and the other point I'm going to make it 1, 3. And so these are 2 points on a graph, 4, 2 and 1, 3, and I want to find, well, what's their slope, okay? Now, if I'm using the formula, then I'm just plugging these in, doing the math, and done. I don't have to draw a graph. I just have to, make sure I'm plugging it in right and then solving it. Once students, first couple times, I promise you, it's going to be a little weird. It's going to be like, oh, wait, did I put this in the right spot? But once you get the hang of it, it is easy. But if it keeps tripping you up, or if you've struggled with negative numbers a lot, even beforehand, you may want to go ahead and keep sticking with a graph and drawing it and doing your slope that way, just to kind of get a bearing of that, to get a bearing of slope. So let's use this though. So I've got an x and a y and an x and a y. Both of these are an x and a y, and this is an x and a y. So first thing we got to point out is the 4 and the 1 are the x's, and the 2 and the 3 are the y's. Don't mix those up, meaning don't make them both x's up here. You've got to make sure this is still the x and y of this one, and this is still the x and y of this one. Now, it doesn't matter which one you make your first point or your second point. It really doesn't. If they're listed side by side or up and down, it may just be easy to name this point 1 and this point 2. Okay? Just because we're used to going up and down or whatever. But you don't have to. But if I make this point 1, then what I'm saying is this is my first x and this is my first y. And if I'm making this point 2, then this is my second x and my second y. Okay? So once you label it, then you do have to, what I mean by I can't change it, I can't make this my first x and this my second y. I can't mix those. So once I make this the first point, then both of those are the first point. And why that matters is then when I go to do my formula, I'm going to put the 3, which is my second y, and I'm going to subtract. Now, this subtraction is not, it's its own thing, and you're going to see that. I'm going to do one here in a second that's got a negative number. But I'm going to subtract then the first y, which is 2. And then that is over the second x, which is 1, minus the first x, which is 4. Okay, so now my problem becomes 3 minus 2 over 1 minus 4. So 3 minus 2 is 1. 1 minus 4 is negative 3. That means my slope is 1 over negative 3. Now, we can make this, because one of them's negative and one of them's positive, we can make the whole thing a negative 1/3. That's fine. But just to keep it straight of what we're kind of looking at here, let's keep the negative with that and then do it with a graph and see if we come out with the same thing. So we've got 1 over negative 3. So let's graph these 2 points. Okay. Those 2 points again were 4, 2 and 1, 3. And so let's make a quick graph. And 1, 2, 3, 4. 1, 2. So 4, 2 is right here. Okay. And 1, 3 is 1, 3. Okay. And we've got this slope going down, right? And then another thing we got to remember though is the slope is also going up this way, and this is why it's going to matter that we would want this as a negative, well, out on the outside. Okay, so let's keep going with this and then just see what this comes up with. So now I know this says 3 over 1 up, Okay, but that's going 3 over 1 up. That's going to find this point out here. So let's make this negative 1/3, right? Because then it doesn't matter which negative it goes with. And realize that if we go 3 over this way, so we go 3 over, so we were at 1 here, and we're going to go to 4. So we went 1, 2, 3 over, and we went 1 down. So we went 3 over this way, and we went 1 down. Okay? So by going 3 over 1 down, we have done 1/3. If you're like, wait, wasn't the negative with the 3? It was. And so we can look at this point and know that it's going to be at, okay, 3 over. So if we follow on this line, we're going 1, 2, 3, and 1 up. Okay? So that point is still on the same slope. This is a negative 1/3 slope. Okay? And so that's finding it on the graph. And that's why when one of the numbers negative, we're just going to put this negative out here, and that way we can find the points on both sides of it. Okay, let's do another one. And from here on, I'm mainly going to be doing the ones as a formula. Every once in a while, I may graph one just to keep that going, but we need to get to where we can use the formula as best as we can. So let's look at 7/3 and 1/4. 7/3 and 1/4. Okay, so 7/3, I'm going to make my first point. 1/4, I'm going to make my second point. This is my first x then, first y. This is my second x, second y. Okay? I think my brain needs the coffee right now. So now I'm going to plug this in. So I've got 4 minus 3. That's this y2 minus y1. And then I'm going to do 1 minus 7. Okay, so that's going to give me 1 over negative 6. And so I'm going to make that a negative 1/6 is my slope. Okay. Now let's do one with some negatives in there. And this is where it does get tricky. And it, can kind of create some confusion. But once you, like I said, once you get the hang of it, keep practicing it, it really does start to kind of mesh and start to work, okay? So I'm going to find the slope between negative 3, negative 2, and negative 4, negative 1. Now, as far as naming it first and second point, that's still the same. This is my first x, my first y. This is my second x, this is my second y. Okay, and so I'm going to start plugging in, but here's where it gets tricky. Okay, this is a negative 1, okay? And then this subtraction is subtracting no matter what this first y is. We've got to go back to our brains when we did substitution. Meaning in pre-algebra, when we substituted, this was not part of y. This was its own problem. And if I'm substituting right exactly what, see, this is all part of the formula, and then now I've got to substitute exactly what y1 is. y1 is a negative 2, so I've got to put in a negative 2. So I'm going to subtract a negative 2, okay? And then down here, I've got x2, which is negative 4. And see, we plugged it in just exactly like it is. We put that negative there. And then you're going to subtract, and then x1. So x1 is a negative 3, okay? And the reason for that is, if we go back to pre-algebra, that is a plus sign. In our integers, if you've got a double sign like that, it's a negative negative, that becomes plus 2. So now this is negative 1 plus 2 over negative 4 plus 3. Okay, and this is the negative rules. This is what I was talking about. If you struggle with negative rules and remembering your double signs, I would keep practicing. I would try these. We're going to get some time to work on them. But then, just kind of keep an eye on that. If you keep making those same mistakes, where you're making those mistakes. You may want to try a graph every once in a while just to check and see if you're going in the right direction, and then go from there, okay? So this one is negative 1 plus 2, which becomes 1. And this is negative 4 plus 3, which is negative 1. And so my slope is a negative 1 over 1, or just negative 1. Because 1 over 1, if you want to go ahead and turn that into a whole number, you can. We're going to leave them fractions when we have to, like 1/3 or 2/5 or something. And if it's a like 8/7 or something, if it's an improper that you can't turn into a whole number, leave it improper. But if you can go ahead and make it a whole number, then you can do that. Okay, so 1 divided by -1 is -1. Okay, so my slope on that one is -1. Let's do one more of those. Okay, so negative. What do I have here? We're going to mix it up now. Put some positives and negatives. Okay, 8, -1, and -2, 4. Okay, 8, -1, and -2, 4. So here's my 2 points, and I'm going to find the slope. And so I'm going to make this the first point, the second point. And so x1, y1. This is x2, y2. And now I start my formula. 4 minus -1. Okay, so that was 4 minus -1. And then that's over -2 minus just an 8. Okay, so that one's kind of normal down here. So this becomes 4 plus 1, which is 5. And this becomes -2 minus 8, which is -10. Okay, now we can reduce it. Okay, and I know it sounds like I'm changing, but the main key is you can reduce them down, you can keep them fractions, you can make them whole numbers. What you don't want is a mixed number. Okay, a mixed number does not give you a rise and run. So, but by reducing, I can make this 1/2, and it is negative because one of them is negative, so it's -1/2 is my slope. Okay, and I leave it a fraction though, because now my slope is, 2 run 2 down 1, or run 2 this way up 1. Okay, so that's what that looks like. Okay. Now, one other thing. So this would be your second day of material here, and I'm going to give you some practice. I'm going to make sure you've got that. I know there's only 4 or 5 problems there, but get some practice with that. Go back and watch them. Do them again. Make sure you're coming out to the same thing. Try the ones I'm going to have for you. We'll check them on Tuesday, and make sure you're heading in that right direction, and we'll kind of re-go through it. But I've got to introduce both of these things since it's 2 days material. The second thing with this is we're going to look at what's called slope-intercept form. Slope-intercept form. It's fancy words for basically, this is going to be a form that will show us where our slope is, and in this case, it's going to show us where our y-intercept is. Now, y-intercept is, like I'm using math terms, and I know a lot of you guys are going, whoa, we just hit the accelerator like crazy. But that's just a fancy word for saying where it crosses the y-axis. So if I've got a graph, what this form is going to tell me is my slope of my line, whether it goes up or down. It's going to tell me, I rise or run so much, rise so much. So it's going to give me those points. And then this y-intercept is also going to tell me where it crosses the y-axis. So if I've got a slope going like this, it's going to tell me this slope, and it's going to tell me where it crosses the y-axis. If I've got a slope going like this, it's going to tell me this slope, and it's going to tell me where it crosses the y-axis. That's all this means here. Okay? Now, that form is written like this. Y equals mx plus b. And it has to be those letters. Okay? Because this formula, it's kind of like the Pythagorean theorem if you took geometry. The a squared and the b squared are the sides, and the c squared is the hypotenuse. These represent specific things. So the y and x are still your input and output. So like you can still plug in something for x and get something out for y. And it's still an x and y on the graph, okay? So it's still a point on the graph of x and y. Like if I plug in 1 and get out 3, then it's 1, 3, okay, on the graph. So, well, it's not that easy, but it's, if I plug something in and get something out, it's going to show me how that affects that, okay? So it's an x and y on the graph. This right here is your slope. So these ones that we were getting like -2 or -1/2, that's going to be right here in front of the x. And it's going to be, a lot of times it's going to be a fraction, like 3/8 or 8/5 or something. It's going to be right here. It's what the m is. And then the b is going to be the y-intercept. And that was, when I remember learning this in school, and I remember thinking, why isn't the y-intercept? Because you still have an x and y. Okay, so that's still just your x and y point. This is going to represent where it crosses the y-axis. This is going to be the y-intercept. Okay, so this form is used to put things in order to explain what that is. Let me put one up there and show you what it looks like. Y equals 4x plus 2. Okay, y equals 4x plus 2. Okay, so y equals 4x plus 2. This is put in y equals mx plus b form. Meaning, okay, you've got a slope, which is 4. You've got where it crosses the y-axis. So like on this y-axis, it's going to cross at 0, 2. Okay, and it's going to have a slope of 4, which we know 4 is 4 over 1. So every time you go 1 over, you go 4 up. And so 1 over 4 up, and also if you go 1 over negative and 4 down, that gets kind of tricky. But you know, if you've got -4 over -1, that's also a positive 4. So that goes that. I don't really want to get that deep into it, but basically, here's your slope. Okay, here's where it crosses the y-axis, and so it's telling you all those things from this. Now, it's still an input-output problem. If I put in 1 for x, okay, if I put in a 1 for x, okay, it's still going to give me an output. 4 times 1 is 4, plus 2 is 6. So 1, 6, okay, is an input-output. If I put in 2 for x, I'm going to get 8 plus 2 is 10, so 2, 10. Okay, those are all still going to be points up there. Okay, but here is, it needs to be in this form, y equals 4x plus 2. Another one could look like y equals -2x minus 3. Okay, all this means is it crosses the y-axis at -3. Okay, so it'd be down here. And then your slope is -2, so it's going to go down. Okay, it's going to go down -2. Okay, so that's what that's giving you. Another one could look like this. I told you a lot of times the slope is a fraction, so it could look like 1/2 x plus 1. Okay, so that means this is going to hit here at +1 on the y-axis. And then the slope is going to be 1 over 2, which means I run 2, go up 1. Run 2, go up 1. It's still positive. It's still a positive number. It's that now you're going over 2, up 1. Okay? So that gives you that knowledge here from putting it in this form. Where we're going to stop with this, what I'm going to have you do is, we have to get any problem into this form so that we can do this work. Now, we're not going to do this yet. That's why I kind of breezed through that. We're going to spend more time on that. But we need to always make sure they're in this form. Okay, this y equals mx plus b. Now, those ones I just wrote were already in that. It was a y equals something x plus b. What you can't have is you can't have a coefficient. So you can't have like 3y. That means you've not solved for y yet. Okay, and you can't have it out of order. So let me put one up there as an example of that. So 3x plus y equals 4. Now, y is by itself, but this 3x is out of order. It's not on this side. Okay, it's got to be on this side. It needs to be set up as y equals mx plus b. So what we have to do is we have to move this. Now, we're not solving in the way of we're going to equal like y equals 2 or something. The x is not going to disappear yet because we don't know what x is. But we do need to move it over here. And I make a joke in class when I talk about this. It's like, when I think about this, I always think about being in line somewhere. And Starbucks is the worst. Like, you stand in line at Starbucks and people get like right up behind you. You ever notice that? It's like, hey, you're not speeding up your time. Like, they're still going to take our order. Like, I never understood. And like, I wonder how that's going to be coming back out into regular society after quarantining. Like, if people are going to be that way. But I mean, it just seems like they're always like right up behind you. And I was actually at a place in NASA that a family kept like people do it with their kids too. They're like kind of have them somehow get in front of you, and then they're like, oh, I guess our kids are, and they end up in front of you. And it's kind of a pet peeve, as you can tell. But I was at NASA, and that started to happen. Like, people just started kind of going around me because I was by myself. I visited NASA by myself that day, and I'm like, okay, I'm still in line. Like, I don't know why it happens, but the reason why I bring that up is we're gonna actually, instead of putting it over here and putting it at the end of the line, it's gonna be that person that cuts. Okay, it's gonna cut in line. So we're gonna take it, we're gonna subtract the whole thing, like we're trying to get rid of it, and we're gonna move it over here, but we're gonna have it cut in line in front of this 4 because we need it to be first. So when it gets there, it's still a negative 3x, and this is a positive 4, and now we're in y equals mx plus b form. Nothing beyond that. We're done. We don't have to solve for y because we don't know what x is yet. We just need it in that form. Okay? So let's do another one. Okay, negative 2x plus 2y equals negative 2. Couple things here. This is out of order, and we've got a coefficient. But let's start with having it cut in line. So we're going to add it this time to get rid of it. We're going to add it over here. And it's going to cut in line right here. It's going to be a positive 2x. We can lose the plus sign because it's first. And it's still a negative 2. Okay? So it cut in line. Now, we do have one more step because we need to get rid of that 2. We can't have it, see, there's no coefficient in front of y. So we have to get rid of the 2, so we're going to divide by 2, and we're going to divide these things by 2. And you can split them up. Okay, and the ones I'm going to have you do, everything's going to come out even. Meaning here, you're not going to, you could have a fraction here because it's slope, but down here it's going to come out even. So 2 divided by 2 is 1x, which we don't write 1x. And negative 2 divided by 2 is negative 1. And now we're in y equals mx plus b. If you've got the 1 there, you're not going to be wrong, but that's your slope, is 1. Okay? But you don't need it there because it's assumed that it's a 1. Okay, so that's my y equals mx plus b. Okay? Let's look at, I'm going to do another one. Negative 5x plus 3y equals negative 6. Okay? So we need to have this cut in line. It's going to cut right in front. Okay? And then we need to get rid of this 3. Okay? Now this will be a fraction a lot of times, so 5/3 x. Okay, 5 divided by 3, we write as 5/3. And then negative 6 divided by 3 is negative 2. Okay? Negative 6 divided by a positive 3 is a negative 2. So now we're in y equals mx plus b form. Okay? Another one. That way you've got plenty of these. Okay? 2x minus 3y equals 9. Okay? So have it cut in line. It's negative. That's still a positive. And then divide by negative 3, because you need to get rid of the whole thing. Which means this is going to be a negative 2 divided by a negative 3, which doesn't come out even, but it's positive now. Because negative divided by negative is positive. I'm trying to give you all the different looks. And then a 9 divided by a negative 3 is a negative 3. So now we have y equals 2/3 x minus 3. And I know this is where it starts to get we are in an abstract world, but it's still an input-output problem. I put something in for x, I'm going to get something out for y. It still tells me my slope, and it tells me where to start on the graph. Okay? One last one. So I want to give this look to it. Okay? Have it move. So we had it cut in line, and the only thing now we need to get rid of is that negative. Can't have it be negative here, so we're going to move the negative over here. It's like dividing it by negative 1. Each thing divided by negative 1 is going to make that a positive 3x, and it's going to make that a positive 4. And now we're in y equals mx plus b because we've got rid of everything but the y. We have our slope. We have our starting point. Okay? All right, I'm going to have you do some work on both these kind of concepts, and then we'll pick up and keep practicing on Tuesday. I want you to find the slope. So these first ones, I want you to find the slope. I'll put slope here. So we've got between these 2 points, 5, 3, and 2, 4. Okay. Number 2, negative 3, negative 7, negative 1, negative 6. Oops, yeah. We wrote them side by side, but you can point 1, point 2 if you want. 8, negative 4, and 2, negative 1. And number 4 is 0, 4. And 0 is a number, so just plug it in like any number. 2, negative 3. Okay? So like, just to give you an example, when I do the x minus 2 minus 0, it's just like a 0. Okay? Then I want you to, so that's your slope problems. Okay? Then I want you to put these in y equals mx plus b form. So you're going to put these in y mx plus b form. Okay, so number 5, you got 2x plus y is 4. Number 6, you got 3x plus 3y is 9. So you need to rearrange these. Number 7 is negative 4x plus 3y is 6. And number 8 is negative 2x minus 4y is negative 8. Okay, so the first 4 problems are slope. The second 4 problems are putting these in order. You're not solving, you're just putting them in y equals mx plus b, and when you get them there, you're done, okay? All right, have a good weekend, guys.